Hi, we want to look this time again at application of differential calculus to maxima and minima problems. Right now, I give you the basic summary of differential functions there. Right. Okay. Now we have to understand something. There's a condition for minima and there is condition for maxima. Now I have to give you these two conditions because we have two conditions basically. Now let's go. The function is, let me say we have a minima and then we have a maxima. For a minimum function, the first condition is that the y, the x must be equal to 0, and the same thing applies to maximum. The y, the x must be equal to 0. All right. When we are solving function that is a quadratic function, we only need just one condition, this first condition. But if it is a function that has from 3 degrees and above, maybe x raised to power 3, then we need a second condition, which is that the square y, the y square, the x square for a minimum function must be greater than 0. That is, it must be positive. Then for a maximum function, the square y, the x square must be less than 0. That is, must be negative. Must be negative. So that is what satisfies conditions for minima and maxima. So let's solve this problem. Let's solve problem. Number 1, find the minimum value. Find the minimum value of the function. Find the minimum value of the function. The function y equals to x squared minus 6x plus 5. Now this is just a quadratic function, so we only need the first condition to solve this problem. Now to find the minimum value, they say we should find the minimum value of the function. Please take note of that. We are not asked to find the value of x for which the function is minimum. No, but we have to find what? The minimum value of the function. So that means we need to first find the value of x that satisfies the minimum, the minima of the equation, that makes the equation a minimum. Then we'll now put that value of x that makes the function a minimum. We put it now into the function to now get the minimum value of what? Of the function. Okay. So now the first thing is we find our dx, derivative of the function, and that is 2x minus 6. Remember, this is going to be 2x is going to be 6. Now, we have the first condition that dy dx is equal to what? Is equal to 0. Since equal to 0, that means 2x minus 6 is equal to 0. So from here, we have our 2x equal to 6, meaning x is 6 over 2, which is what? 3. So we have gotten the value of x that makes function y a minimum. This value of x makes this function minimum. So to find the minimum value of y, that is finding y minimum now, finding y minimum therefore is going to be, when we put this x value into the function, so that's going to be 3 for x, that's 3 squared, then minus what? 6. What is x? 3. Then plus what? Plus 5. Can you see that? So instead of writing x, we are writing 3. So we have 9 minus what? Minus 18 plus 5. So our answer is going to be what? Our answer is going to be that's 14. That's minus 4. So the minimum value of y, or of the function, is minus 4. The minimum value of the function is minus 4. Alright, so that is it. Alternatively, since it's a quadratic function, we can say y minimum, although it also holds for maximum, y minimum is equal to what? 4ac minus b squared, over 4a. So this one satisfies the conditions also for finding y minimum or y maximum. It holds for the two. So our a is 1. Remember from here, a is 1. And our b is what? -6. And our c is what? 5. So you substitute this one into the function. What do we have? 4 times a, then times our c, which is 5, then minus b squared. B is what? -6. So you square that over 4a. 4 times what? 1. So we have 20. Now -6 squared. That is 36. So minus what? -36 all over 4. So that's -36 over 4. So that's -16 all over 4, giving us what? -4. So can you see that? So we still get -4 as the minimum value of the function. Alright, now let's solve another problem again. Find the value of x. Find the value of x that makes this function, that make the function. Find the value of x that make the function y. Function y equals to x squared minus 8x plus 7 minimum. Find the value of x that makes the function x squared minus 8x plus 7 minimum. Of course, it's a quadratic function. It's going to be dy dx, therefore equals to 2x minus 8. So when we differentiate, this is what we're going to have. And then the minimum point, of course, dy dx is going to be 0. So that means 2x minus 8 is equal to what? 0. So 2x is equal to 8. So x therefore is 8 over 2, which is what? 4. So therefore x equals to 4. So this is the value of x that makes this function minimum. Alright, alternatively, we have a quadratic function. Please, this only applies to quadratic function. X, the value of x that makes a function maximum or minimum is given by minus b over 2a. Minus b over 2a. And know that our a is what? 1. And our b is what? -8. So that's going to be minus 8, because b is what? -8 over 2a. 2 times 1. So that is what? 8 over 2, and that is what? 4. So the value of x is what? 4. As in agreement with what we got earlier. So the value of x that makes the function minimum is 4. So I think that answers our question, and that solves our problem. And I believe you have actually learned something. I really want you to make the most of your exam that you're preparing for, and to do that, you need to burn the midnight candle, and that's what you are doing. I really appreciate your effort for going extra mile, and I wish you the very best in your forthcoming exam. Thank you.